Good day wherever you are. My name is Teacher David. If you have not heard my name, I am Teacher David. Yes. So as you prepare for your exams, I want to take you through chemistry, paper 3. I know there are some kind of setting that you have never seen. And this got the 2017 group off guard. You see, the trend of setting chemistry paper 3 was you are given that the instructions, you follow the instructions. For example, you will be told if you are doing qualitative analysis. In fact, here I'm talking about qualitative analysis. You are told to the first portion, okay, you are being given solid. You are told to prepare the solid, the solution, add about 80 grams, and then you are told to the first portion, add this. Now in 2017, they were not used to writing the procedure for themselves. So in 2017, they were supposed to write the procedure and know the expected observations like we do in biology. You see that? Therefore, most of them, they were caught off guard, and that's why in 2017, the performance for paper 3 was indeed poor, very poor. So I want to take you through chemistry 2017 so that you can get the same paper. Will you be able to write the procedure? Will you be able to write the procedure? If you are given the reagents, are you able to write the procedure? That is the question you ask yourself. So you should be prepared for anything. You must be prepared for anything. Right? Thank you. Let me take you through chemistry 2017, follow step by step, where the learners were given the reagents. They were supposed to describe, write the expected observation, and then finally you to write the problem. It was like biology, exactly biology. Remember biology, the learners, food test, the learner writes the procedure, expected observation, and a conclusion. That is what was there in chemistry paper 3, something that was never set another day. And that's how it got students off guard, and they were unable to understand what was happening. So, remember to subscribe kindly, and powder, and Kcse 2017, Kcse 2017 paper 3, to go through this paper and many others that we are going to do. You are provided with a solution B powder, solid B2, acidified potassium permanganate. You are required to determine the enthalpy change for the displacement reaction between metal B1 and copper 2 salt. So first, let me, as I do always, let me remind you what these things mean when you are given 0.5 copper. That's what it means. This one also means moles of the potassium permanganate. Capital M stands for molarity, is equal to 1000 centimeters square. Cube. Centimeter. Place 25 of centimeters cube solution A into 100 meter plastic beaker. Allow to stand for 1 minute and then measure the temperature according in the table. Add and measure the highest temperature reached. This will take about 5 minutes. Record the reading in the table 1 as initial temperature. Initial temperature, you just measure, you put, it depends to where you are. For most of the people, it will be 25. So it depends. So 25.0, 25.0. Depends on the solid provided. In this case, the temperature rose from 25 to 43.5. The temperature rose to 43.5. The temperature rose to 43.5. Now we need to get the temperature change. Temperature change is to subtract. So when you subtract that, you find that it is 18.5. 18.5. And you have to calculate the number, Roman 1, number of moles of copper 2 sulfate used. Copper 2 sulfate used. Copper 2 sulfate is solution A. Remember, you need always 2 sulfate. Now, we have been asked to go back to the procedure. You pipetted 25 of solution A. So, 25 centimeters cube of copper was used. 25. So, M that we have used only 25 centimeters cube of solution A. So, you ask here 25. So, you ask here 25 centimeters. So, this you cross multiply, you divide by 1000, 0, 1, 2, 5, 0, 0, sulfate use. Sulfate use. Whenever the question starts here, calculate the. We start from. Whenever the question starts here, calculate the. We start from upper. Calculate the. From upper. Calculate the. Enthalpy mixture specific heat capacity is that J gram for that, and the same J gram for that, and the same, and density is 1, and density is 1 gram for the solution. The molar 1 gram for the solution. The molar enthalpy fast change is given by capital M, capital C, and so the solution we use DX copper 2 sulfate. What solution we use DX copper 2 sulfate? What was the volume of copper 2 sulfate? The volume was 25. So now we need, we were supposed to pipette, let us go back to the heat change that was used. Let us go back to the heat change that was used. C is specific heat capacity, which is always provided here. And then in temperature change. The temperature change, we had already done that. So first we go back. So if you have forgotten the volume you used, you pipetted 25 centimeters cube of solution, 25 centimeters cube of solution A. So the solution that was used in the experiment is 25. So we have everything we need. Remember, we have used 25 centimeters cube. So 1 centimeter cube is equal to 1 gram according to the density of water. Centimeters cube will contain how many grams? Good as the mass 25 grams. So that one will be 25 grams. You divide by 1000 to convert it to kilograms. Molar temperature is 18.5. So this one will give us 91.9. 1. This one will give us to something like this. Now, what we have is the mass that was produced by this solution 25 was able to produce these moles. Now, what we want to know, what will be the number of moles that we want to know? What will be the number of moles that will be produced by 1 mole, because we want per molar. 25 kilojoules were produced by the number of moles we calculated above here, 0.012. We'll produce how is this, divide by that. That is now 1.9425 divide by, give us 155, 155.4 kilojoules, 240 something, equal 40 what? 240. Therefore, you should be able to remember from there negative 155.4 kilojoules per mole. So don't forget, you should be able to indicate whether the reaction was. Repeat procedure B1. The maximum temperature reached about 8 minutes. Record the temperature readings in the table here. So the temperature was as follows. The temperature here, when you did that procedure, this was 37. The difference was 13.5. Now, when you compare the change for T2, remember here, the change T here, the change here you can see is change T2, temperature change T2, temperature 2, and we had the temperature 1 in our first procedure. We had this one was indicated as temperature 1. There is 13.5. The question now comes here. Compare the change in temperature T1 and T2 and the same experiment but using different metals. Why are they there different? So this depends on the reactivity of metals in the reactivity series. Those that are more reactive, so you comment and say that temperature T1 is larger than temperature change T2. Then we need to say metal B1 is more reactive than, hence greater change, greater temperature, hence greater temperature change. About the energy changes, so you need to prepare very well for the question of energy changes in both paper 3 and even paper 2. You need to be prepared for this year's exam. Procedure 2, let's go through procedure 2. Fill the purate with solution C. Fill the mix also tells you very well that you need to, the reason why you are told to go through the paper for 15 minutes, this is now, there's somebody who could have done the experiment in procedure 1, alafu akamwaga ile solution yenye alikuwa amefanya nayo, akaimwaga. Kwa sababu hakusoma hiyo procedure. That's 15 minutes you're supposed to read from instruction to the end. So when you see that procedure 2 requires you to use what you did in procedure 1, then you should be able to note down that you don't need to pour down the volumetric flask, wash the residue, water to make up the mark, label the solution, solution B2. Using a pipette with solution C until the permanent pink color just appears. Record the table below. Now, ni muhimu kuelewa ni nini inafanyika kwa procedure because procedure ndio inakufanya uelewe. Kwa hivyo tulikuwa na solution B, procedure 1 part B, procedure 1 part B. So we have done this experiment, we have done this one. Hii solution yenye imebaki hapa. Lakini hapo uliambiwa retain the mixture for use in procedure 2. I think that's where you're supposed to mark that so that you don't pour down the. So B2 solution is ion solution. We are aware of that. Now, we are not using an indicator here because we are using an oxidizing agent which is certified potassium permanganate. So, what was the final reading according to this experiment? Solution C is acidified potassium permanganate. You need to know that. Now, once you have done the procedure, let's fill the table. The table should be filled with, you can fill with 1 decimal place. So my is 12.5. Initial is 0.0, 0.0, 0.0, just repeat it. And my second 12.3. 12.3. So you subtract here, you find it is 12.5, 12.2, 12.3. So look at this. Are they in the range? So this one you can do the average with only those that are very close, this and this. Average fanya na hizi mbili. So average, so that upate the more, your answer to be more accurate. So you will do 12.2 plus 12.3, you divide by 2. That one will be even more accurate because you can see 12.1. Now this one will give us 12.25 centimeters cube. The equation of the reaction between two ions and manganate 6,7 is as shown there. We have been given. Calculated the number of moles of potassium permanganate 7 used. That one is very simple because we know 0.02. So we say that means that 0, the average 12.25 centimeters cube. Solution C ndio tumetumia 0 moles. That is the number of moles of the potassium permanganate that was used. Ion, calculated the number of moles of ion 2 ions in 25 solution B used. 2 and the permanganate from the equation. It means that 1 mole here, there is 1 here, 1 mole of the volumes of ion. Then now we have the mole ratio. Then you should now ion, but moles of the ion, the manganese 0.00025 moles is equal to 1. That is for potassium permanganate. What about 0.00245? So the moles of the potassium, the ion, 2 ions, is 0.01225. That ion that reacted with a copper 2 sulfate. Now, copper, the ion in the volumetric flask. That's the procedure we did in the procedure 2 above. Let me not go back. So, but we know the number of moles of 25 of this solution. The number of moles we know, centimeters cube, 0.01225. We will ask copper from procedure centimeters cube of solution B. 5 equals 0.01. The number of moles that reacted with the copper 2 sulfate will be exactly the same. This is 250, 25. The copper, the ion of 225 moles with ion. Ion is 0.0. So the mass is 6 grams. That is it. You are provided with, so 2017 qualitative analysis. This was the year when the qualitative analysis was somehow very different from what we are used to with what we are used with. You are provided with solid K, aqueous ammonia, aqueous sodium sulfate carbonate. So out consecutively to confirm if solid K is lead to carbonate. Write the tests and expected observation in the place that now this time around like what we are used to. Very nice. Let's look at it then. Would you start with ammonia? Would you add ammonia solution to a solid? No. Will you add aqueous sodium sulfate to a solid? Because lead is suspected to be, you need to do. So the first thing, to solid K in about 10 centimeters cube of nitric acid provided of dilute nitric acid provided. You don't need to write this, but it's okay. Retain the mixture of test 2 and 3. Effervescence will occur. Remember, you are not doing the experiment. You are writing what you expect, because we know when an acid is reacting with a carbonate, effervescence should occur. You are not doing the practical. You are just writing things from the knowledge you have from what you have learned. That an acid plus a carbonate, it will produce effervescence. And what gas is going to be produced? That gas should be carbon dioxide. And the carbon dioxide, what does it do to the wooden sprint? It will extinguish. So hapa tunatumia tu the knowledge that you have learned. Effervescence is the same as viscing. A colorless gas that extinguishes. A burning splint. My friend, plus nitric acid. This is what you learned in Form 2. Is it 3 or 3? This will form lead nitrate plus is fire extinguisher. Remember, one of the uses of carbon dioxide is using fire extinguishing. So this gas, when you brace, and so that is, we are just using this knowledge to write these observations. Next test. Now we have the solution. Then we will observe what will happen. To about this one in chemistry, and it has come to about 2 centimeters, to 2 centimeters cube of the mixture above. Add ammonia solution, dropwise. We expect, remember, we are not doing an experiment. A white PPT, this is lead. A white PPT is going to be formed. With the white precipitate dissolved in excess to be, it was suspected to be lead, then ammonia. If it was sodium hydroxide, then the white precipitate will be formed and it will dissolve. But this is ammonia is insoluble. Which is insoluble in excess. To form sodium hydroxide, lead is an amphoteric. It's among the ZAB, zinc, aluminium, and lead. You are not doing the experiment back. Again, you can say about 2 centimeters cube in Roman 1 above of sodium sulfate, aqueous sodium sulfate. A sulfate with lead, it will combine to form lead sulfate is going to be formed. White PPT is formed. Except lead sulfate, barium sulfate, calcium sulfate. So if this is lead and we are joining it with sodium sulfate, the lead ion will combine with the sulfate ions to form lead sulfate, which is insoluble. To find out whether what we have written, carry out tests in the places provided. So that's A. So in the performance in chemistry, paper 3. So now you will be required, you will be provided with the solid K, you will be provided with the reagent ammonia. So when it was done, or effervescence occurred, a colorless gas. Then it means the gas that was produced, it is CO3 tested. We were adding, because we are using our procedure, we were adding ammonia solution to observation. Now you add the PPT insoluble in excess. So that one will not be, because now we are doing the experiment, you should be able to tell us what is there. When you are adding ammonia, a white precipitate is formed and it is insoluble in excess. Then what is my aluminum? Because when we are adding ammonia, zinc is absent. Because if it was present, it will dissolve in excess. Zinc is absent. So if it is absent, we don't want what is absent. What is present? But you just write magnesium 2 ions, or you can even put even barium. Because now zinc is absent, what would be from our procedure number 3? Procedure 3 was, remember we are using this experiment in this part P. The observation in the actual experiment, there was no 2 ions was present. This one, it is allowed for you to write lead, because if there is no white PPT, it means lead is absent. But in this case, magnesium is present. So always write the positive answer and not the negative one. Record your observation. Place all solid M in a test tube, pouring tube. Add 10 centimeters of dilute water, distilled water, and shake. Retain the solution for the use in procedure B, Roman 1 to 3. So tell us whether the solid dissolved. For the case then, and the M is polar. To the first portion, add all of the sodium carbonate provided. Sodium carbonate, always we expect it is either effervescence will occur or it will not occur, and the answer is always the same. So in this case, there was no effervescence, no VC. That's one way. Or you can say no effervescence. So there, it will react with the acids is absent. If effervescence occurs, if VCing occurs, bubbles, you see bubbles, then it means R-COOH is present. So the word absent and present is very important. Usiandike RH unawache. If it is there, you say absent, present. If it is not, absent. To the second portion, add 2 drops of acidified potassium. It is used to test for the double bond change. So acidified potassium permanganate test. So if you don't know the color of initial, it is important you write like this. Is it you will say the purple acidified potassium permanganate changes the color this double bond ROH. ROH stands for alcohols. Ethanol, butanol could be present. So let us do the third one, 2 centimeters of acid. Then now the color of orange to green, then it confers to test for alcohols. Right? In organic chemistry, change to green. Changes to green because this was after boiling. Okay, you can say on boiling, on heating. Then if that is the case, then it confirms that the alcohol, is the one that was present. Thank you very much. Remember to share and subscribe. Thank you. Remember to like and share to as many people as possible. Like, share to as many people as you can. Write the procedure. Give the expected observations, and then use that observation to do what? To do the experiment. So can you imagine if the student did not write the correct procedure? It means that so prepare for such kind of question, because you never know. So can you imagine if the student did not write the correct procedure? Thank you.